Very good morning, friends. We have seen about the mechanism of heating by using microwaves. It has been seen that the dipolar polarization and the additional effect like interfacial polarization or ionic conduction mechanism are followed for heating the molecules by using microwaves. Here, the microwave effect is not only the thermal effect. This is not only the effect which is responsible for enhanced reactivity and selectivity. There are another factors also. The specific effect of thermal heating is explained by rationalizing the various factors of Arrhenius law, which state that k is equal to a into exponential of delta g into r into t. The pre-exponential factor a this a represents the probability of molecular impacts. In turn, is dependent upon the frequency of collision of the molecules. And this collision frequency is in turn proportional to the vibrational frequency of the atoms. This vibrational frequency is affected by these microwaves. Thus, by optimizing this vibrational frequency, we can increase the rate of the reaction. Another factor, the post-exponential factor, that is delta G, that indicates the degree of freedom, affects the heating or affect the reactivity and selectivity. Delta G is given as delta H minus T delta S. Delta H represents the enthalpy of the reaction or heat of the reaction. Delta S represents the entropy of the reaction. Another factor which is affected by microwaves is T delta S. The T delta, optimizing the T delta S and the degree of impact, these factors affect the reactivity and selectivity. Other than this thermal effect, we can also see medium effect, or otherwise it is also called as solvent effect. The solvents which we use are generally the polar solvents like dimethyl sulfoxide, dimethyl formamide, water, ethanol, methanol, chloroform, etc. These polar solvents has good absorption of microwaves as they are having polar ends, which aligns in the along with the microwaves in the electric field, and with the changing electric field that increases the friction, and from these solvents the energy is transferred to reactants. In case of non-polar solvents like benzene, carbon tetrachloride, toluene, xylene, etc., which are microwave inactive, then also reaction can be carried out. In these cases, there is direct interaction of the microwaves with the reactants which are dissolved in these solvents. But however, the results of that will be different from the reactions carried out in polar solvents. Another effect which we see in microwave heating is superheating effect. It is observed that when solvents are irradiated with microwaves, they will be heated more than 13 to 26 degrees than the conventional boiling point at atmospheric pressure. This superheating is explained by inverted heat transfer effect. Here, in microwave heating method, the transfer of heat arises from the irradiated medium and moves towards the exterior as the nuclei which are boiling are formed at the surface of the liquid. That's why the superheating effect is seen in case of multimode reactors. When non-polar solvents are used and they are superheated and they are used in multimode reactors, it undergoes bumping and explosion. Various solvents here are given along with the dielectric constant and the dielectric laws. And by tan delta is given as epsilon by epsilon dash, that is dielectric constant divided by dielectric loss. Depending upon that, we can choose the type of solvent which can be used for the reaction. Next, the solvent selection plays a very important role in the microwaves for the reaction to occur. Just it is not the thermal effect, it is also the additional solvent effect we can see in the reaction. The microwaves penetration also plays a very important role. The frequency range of 500 to 5000 megahertz for efficient heating and for the attainment of the required depth of penetration. For industrial application, 433.92 megahertz frequency range of microwaves are utilized. For laboratory use, 915 megahertz frequency range of microwaves finds its use. For medical use, 5800 megahertz microwave frequencies are used. For cooking purpose, 2450 megahertz frequency range of microwaves are used. As this graph indicates, the frequency is represented on x-axis and depth of penetration is represented on y-axis. As we see, as the frequency goes on increasing, depth of penetration goes on decreasing. Lower the frequency, deeper is the penetration. But however, there will be lower heating. Higher the frequency, lesser the depth of penetration. Thus, it is having faster heating. While using the microwaves for the reaction, the selection of frequency plays a very important role. Both the depth of penetration and heating plays an important role. Thus, the wise selection of the frequency is a must for getting the reactions done. There are merits and also limitations in microwave heating. One of the best merits or advantages of microwave usage for heating is it substantially reduces the reaction time, which is achieved by enormous increase of acceleration of the rate of the reaction. Because of this enormous acceleration of the rate of the reaction and reduction of reaction time substantially, it improves the yields by decreasing the decomposition. This is the major advantage of using microwave for heating. Other application includes the drying and melting of samples of varieties of not only organic nature and also inorganic nature. The inorganic synthetic reactions can also be carried out by using microwaves. Many of the time we go for solvent free reactions, which is called as neat reaction. Sometimes we take the reactants, adsorb onto the solid support like clay or silica gel or aluminium or montmorillonite and irradiate with microwaves. This come under the category of clean reactions, and both the clean reactions or neat reactions are the essential aspects of green chemistry. The objective of green chemistry can be met by using the microwaves in neat and clean manner. Microwave heating also offers advantages of least operator intervention, least contamination and least loss of the material, along with improved safety and has a greater reaction control. The usage of continuous flow microwave system allows sample digestion, that is solubilization of the samples, and also helps in extraction in the online system, which can be given for direct analysis. In continuous flow reactors also microwaves can be used effectively. Microwave assisted synthesis not only reduces the reaction time and accelerate the rate of the reaction, but also the desired chemo, regio and stereo selectivity can be achieved. Is another advantage of microwave reaction. There are limitations also. What are these limitations? Whenever we use the nitrogen atmosphere, or when the substances which are lacrimator in nature or corroding substances cannot be handled by microwave. The higher temperature achievements leads to superheating, and because of this superheating, decomposition of the products may be possible. That's why multi-mode microwave reactors are of not the choice for laboratory reaction. As they are heated, thermodynamically stable products are favored in preference to kinetically favored products. Thus, kinetically favored products cannot be achieved by microwaves. This is another limitation of microwaves. The metals are reflective to microwaves. Thus, radiation tends to bounce off them like light from the mirror. Thus, when metals usage should be avoided. Otherwise, it gives to electric sparks. The closed reaction results is possible when we use Teflon tubes or the apparatus made out of Teflons which can withstand the pressure. Otherwise, the closed vessels cannot be used. Domestic microwave ovens, the power level what we use is not homogeneous within the system. That's why homogeneous heating is not possible. Hence, domestic microwave ovens are not the choice for laboratory reactions. It may be useful for just cooking purpose. These are the few limitations of the microwave heating. In the next presentation, I will be dealing with the applications of microwave heating. Till then, have a nice day. Thank you.